Well, hello, East Rockaway. Welcome to a little bit of Earth's history, page 8 and 9 of the reference table. So please get out those reference tables. Have them open to page 8 and 9 with it digitally or your hard copy. I have mine right over here. Could be printed. I'll be pushing out a PDF of page 8 and 9 that you could always use as well. Anyway, so this is Earth science. And let's go and move forward because this could be quite a bit. All right. Anyway, so Earth's history. Why do we care about Earth's history? Well, because we want to understand what happened in the past, right? We want to know things like volcanic eruptions and uplift and subsidence and deposition and impacts, ice ages, some of the cool organisms that maybe lived, right, that we're finding in the rock record. And that's exactly it. How do we know what was going on back in the day? It comes down to the rock record, like we were talking about. Relative age dating, superposition, oldest at the bottom, youngest at the top. We see these organisms down here. We say, oh, these were the ones that are older. The ones up here are younger. And then we say, let's see if we can test them to figure out how old they are. So some of this stuff might blow your mind. All right. Here is page 8 and 9 of the reference table. Whoa, you see that thing and your mind is blown, right? 2 pages, all this information. What the heck is going on? Well, that's what really today's lesson is going to be about. All right. So you really need to pay close attention. Have that reference table right out in front of you. All right. And so let's move forward here. All right. So, but along the top here, you can think of these are the vertical columns here. All right. And then there's things going across horizontally. All right. We're going to try and figure that out. But an eon, whoa, eons represent a really long period of time broken up into eras. And then we can break eras even into smaller periods or increments, right? Periods here. Oh, Jurassic. How many of you heard of the Jurassic period before? I think all of you have. Epochs, all right? A little bit smaller period of time. All right. And then they also break up how many millions of years ago things were occurring. Life on Earth. And of course, I go to Jurassic and abundant dinosaurs and ammonoids. All right. Don't worry so much about that right now. Some of the rock record in throughout New York State, some of the fossils that lived, the organisms, and we can see all our fossils along the bottom here with the different letters. Important geologic events in New York State, all through in here. And then finally, what we think, the dark region on here, that's supposed to be North America, where we think North America was throughout geologic time. And remember, we think through plate tectonics, the continents have shifted, right? Think back to we talked about Pangaea, the supercontinent of Pangaea. We're going to see that in here. Pangaea probably existed somewhere in here, okay? Right at the end of the Paleozoic, beginning of the Mesozoic. We're going to get to that. All right, anyway, have that reference table out. All right, so no better place to really see a good representation of the rock record is in the Grand Canyon, all right? Oldest at the bottom, working their way up all the way to the top. And most of these rocks are sedimentary. They're probably going to have fossils in them and some really good fossils, which we're going to talk about. All right, how about New York State, though? Oh, New York State. Here's some rock record throughout New York State, right? And I just have that little from the geologic time scale there. And you can see these looks like some sedimentary rocks, right? Limestone, shale, and dolostone. And sure enough, now I know we're talking page 8 and 9, but I want to just show you something right here. We've seen some of this already, right? This right here we use for latitude and longitude, but also page 3, this is page 3 of the reference table, the different types of symbols on here represent the different types of rocks and the geologic period we think these rocks formed in. And most of these rocks are sedimentary. And if we think back to sedimentary rocks, New York State in its geologic past was probably submerged below sea level, because that's really the only way you're going to get all these sediments to be deposited. The other thing that we're going to find in a lot of these sedimentary rocks throughout New York State that are thousands of feet, hundreds, if not thousands of feet above sea level, we're going to find fossils that once lived in the water, which says, oh, this New York State must have been submerged below sea level at one time. Through uplift, now the rocks are sitting above sea level. Anyway, so you can see all the different, we're going to see all these geologic periods in the reference table. Anyway, all right, so here we are. We're going to focus in, right? I kind of enlarged it here. You can kind of see we're going to focus in on this little section over here, all the way to the left under eons. So let me just advance, all right? Oh, sorry. I'm just showing you, I'm breaking up the table. You can see the periods there, distribution of fossils. These are all the vertical columns, all right? So anyway, now we're going to break up. We're going to try and break up what's going on in the eons here, okay? You can see here are the eons, right? We see the word pre-Cambrian, before the Cambrian, because we're going to see the Cambrian come up. It's one of the first more recent, not really recent, but in the more recent eon, okay? But we're going to focus in on the eons here. And sure enough, so you can see I took this right here, right? And I just sliced it out, and I've got the eons. And we've got the Precambrian, and we've got the Phanerozoic. Let me get this thing out of here. Let me get that out of here. Oh, I think that'll go. All right. Oh, sorry. All right. Hold on. Let me get that out of there. It won't move. All right. Anyway, so it won't move. But if you follow the arrow, okay. Anyway, we got the Precambrian and we have the Phanerozoic. All right. And sure enough, if you look at the bottom, right, it says 4,600. That's the start of time. That is the beginning of the Earth and solar system. 4,600 million years ago. We're going to just say 4.6 billion years ago. That's what these abbreviations along the bottom here are. And I don't want to pull that up, but BYA, billions of years ago compared to millions. It's the same thing. It's just the reference table represents it a little bit differently. So we go all the way up through the Precambrian, which is broken up into the Archean and the Proterozoic. And then right here, it's about 544 million years ago, we enter into what we call the Phanerozoic. That word says Phanerozoic, right? And the Phanerozoic runs from about 544 million years ago to present. And you can see here, present day at the top here. And what's interesting is when you just look at this right here, it really shows you the Precambrian is broken up. The Precambrian represents, it's like over 80% of geologic time. It's something between 80 and 90% of geologic time. So from 4.6 billion to 544 million years ago, it's the Precambrian. So the last 544 million years ago, we're in the Phanerozoic, which, is only, I don't know, about 15% of geologic time. Only. Anyway, so let's see what was going on in the Precambrian, okay? Actually, before we get to the Precambrian, right, this is just breaking up geologic time in a 24-hour time period. And we're working around clockwise here. And if you notice, right, all of this going all the way around, right, we keep going, we keep going, we keep going, we keep going, all the way around, okay? And, you really, the first, let me pause this for a sec here. Hold on. Exit. Oh, pause. And pause. Okay, I think we are back. Let me continue to present. Sorry about that. I just wanted to show you this, right? And if we could break up the 4.6 billion years into a 24-hour time period, right? That's this right here, and you can take a closer look at this. I'm going to go through it quickly. The whole point is there's not much going on for the first several hours, all right? I mean, even here, right? First plant life appears, right, as a green algae, which is probably stromatolites, which I'm going to show you. Anyway, I'm going to just fast forward right here. Some of the things that we're probably more familiar with, okay? First dinosaurs appear at just before 22 hours into a 24-hour day. What's crazy, right, is modern humans, okay, appear at 23 hours, 59 minutes and 56 seconds. 4 seconds, right? That's 4 seconds uh, left in a 20. If we could break up 4.6 billion, I know that's blowing your minds here, but in those 24 hours, humans appear for the last 4 seconds. So we really haven't been here that long. All right. So I'm going to just show you a quick little video. All right. It's just another scale breaking it up. And here's a little YouTube video showing.
Ever thought, what if Earth only existed for 24 hours? In the first 10 minutes itself, the Earth collides with planet Theia, resulting in the creation of Moon, without which our days would have been only 6 hours long. Life originated at 4 a.m. with unicellular organisms, the true ancestors. Teaspoonful of soil contains more organisms than all humans. The single-celled organisms have moved to multicellular organisms, and life begins to prosper on Earth as we see the first instances of sexual reproduction. Seaweed has started growing, and oxygen is now spread across the Earth's atmosphere. Marine animals, who take up 99% of the planet's population, only came into existence in the last 3 hours. It is only now that we see land plants growing. Yes, the marine life came even before the plants on Earth. Think about this the next time you order yourself a seafood platter. It is not until 10:56 p.m. that dinosaurs appear. Wait, we're still at just dinosaurs? But as our history books tell us, the dinosaurs went extinct, but the mammals survived. It is already 11:39 p.m. and no humans? The day is almost over. You must be wondering, when do we arrive? It took almost 4.6 billion years of evolution for us to exist, and we have changed so much in so little time. The Homo sapiens of today have only had a culture for less than 50,000 years. Do you think there's still time?
Okay. All right. So let me just pause everything here. Okay. So let's take a look at the Precambrian, right? So remember, this is where it said eons, right? Here's the Precambrian, right? 88, 85% of geologic time, starting here, working our way all the way forward here, right? And, if we zoom in a little bit, if we zoom in a little bit, right, we can see, and by the way, I have, it's blocking me again. Anyway, if you notice, right, I put in, this is like a Star Wars planet there. Can't think of the name of it right now, but that's probably what the Earth might have looked like early on. One big ball of lava as the Earth began to cool, starting to create an atmosphere and so forth. These are all the things that are starting to happen during the Precambrian, all right? It says here at around 3.5, about 4.2 billion years ago, the oldest known rock. 3 around here, you can see here 3.8 would be, our stromatolites. And stromatolites are cool because we study modern day stromatolites. There's a picture of a modern day stromatolite. It's a tropical photosynthetic organism that lives in the ocean. When you hear the word photosynthetic, remember, photosynthesis, right? Taking in carbon dioxide, giving off oxygen. So these are probably the organisms that are starting to help create an oxygen-rich atmosphere, which probably didn't exist down over in here, okay? We work our way through, right? And so this whole section here, and it kind of drops down. I'm just going to zoom back up. You can see here if you look along the bottom, we follow it down along the bottom here, right? And it talks about at 1.3 billion at the bottom. You're looking down at the bottom there, because if I bring my, okay, you see abundant stromatolites, right? This is probably helping to make the atmosphere very rich in oxygen, right? And they talk about, you can see at 5.8, you see the 5.8 right here, Eukaryotic fauna, first multicellular soft body marine organisms. Now, so guys, the point is, I'm trying to emphasize here is that the bulk of the table that I blocked off here is really only, I don't know, 15% of geologic time, but we have the bulk of information from there because the more recent you get to modern time, the more rock record there's going to be, the more evidence of it. Right? Things get destroyed over time, so the really old stuff has probably been destroyed through the rock cycle, recycling rock and so forth. Anyway, so this is the Precambrian, okay, and they kind of keep most of the Archean and the Proterozoic over here. It's really just this right over in here where we're at about 1.3. This is the 1.3 that they're dotting down along the bottom here, right? It's coming down along the bottom here, and all the way. So this is the 1.3. This is the 544 that comes up along over in here. Okay. All right. So let's advance. All right. Stromatolite fossils. Okay. All right. So let's move on to see, here we are. Let's move on to what we call the Phanerozoic. So remember, we just looked at the Precambrian. We're going to look at the Phanerozoic eon, all right, which is going to lead more to recent time, all right? So here we go. The Phanerozoic is broken up into the Paleozoic, the Mesozoic, and the Cenozoic era, right? Oldest down here, youngest up here. And just so you know, all right, these are the organisms that we think were living in the Paleozoic, right, Mesozoic, and Cenozoic. And sure enough, we are living in the Cenozoic, okay? Some organisms you should be more familiar with, okay, that you see. Some have gone extinct, but some have not, okay? So if we advance, right, Paleo meaning old, Meso middle era, and Ceno meaning recent era. Okay, so here's the Paleozoic, and I try to show you that the table continues all the way across, right, across page 8 and 9, right? So we're reading this horizontally across now, right? And so that we've got the Phanerozoic eon, right? Paleozoic era, and then we have all of these periods here. Cambrian being the oldest, Permian being the youngest. Now remember we were just looking at the Precambrian, right? Well, here's the start, right, of the Cambrian, right? And by the way, they break them up into late, middle, early, all the life on Earth, the possible rock record throughout New York State, the fossils that we might find. And we're going to see, we'll talk about a few of those, important geologic events, and then it's cut off here. Then we get into the land position of the different continents, okay? So here we go, a little close up there. And the Cambrian starts at about 544 million years ago and goes to about 250 million years ago. And then it ends. And then we move into that next era. Okay? Cambrian, Ordovician, Silurian, Devonian, Carboniferous, broken up into Mississippian and Pennsylvanian, and Permian. Okay? Just you can see right there. I added that slide there. A little close up here. And you can see this is the life on Earth during the Paleozoic. The Eurypterid New York State fossil, right? You can see abundant Eurypterids. That's the Eurypterid right there, which you'll also see along the bottom. Here's a fossil of an insect. So, age of the insects probably, and fish and so forth. And sure enough, I have a fish fossil. I think it's a siltstone. All right, you can see that. You might be able to see the layering there. Okay. Actually, there's another imprint on that side there, if you can see that. But yeah, here's my fish fossil. And you can see right here, it says abundant fish right over in there. Okay. And here is my Dimantrodon, right, which might look like a dinosaur, but it's probably something that evolved into a dinosaur. So this is some sort of reptile, mammal-like. Excuse me, it is a reptile. Okay. Anyway, and that was during the Permian. And then sure enough, boom, mass extinction of many land and marine organisms. I will say this, the end of a lot of these eras are marked by a mass extinction, meteor impact, major change in climate. These are the kind of things that will not allow a species, will cause extinction of many species. All right, anyway, a whole bunch of information in here, right? Okay, you can see these are some of the organisms, right, that are living, the letters correspond with the fossils along the bottom, right? So I'm going to stick with the trilobites. See where it says trilobite here? Trilobite, basically, if you notice, the bar starts right here at 544 million years ago at the beginning of the Paleozoic. The bar ends here. It means trilobites went extinct. If the bar ends there, trilobites went extinct. They went extinct at the end of the Permian, which there was a mass die-off. Other things did live through. That's why you can see the bars continuing, okay? Um, but you can see letters A, B, and C. A, they're saying A, right? Let me just forward. Let me go. A, this is A right here, right? A lived during the Cambrian. B lived during the Ordovician. C lived during the Devonian. They evolved and or went extinct. Anyway. So there's that's just the whole thing. I'm just showing you how the trilobites ended here. Some of them you can see lived almost as long and can still continue to live today, like the nautiloids. Look at the birds. The birds came in here, still living today. Coral, coral came in down here, still living today. Anyway, so all on the bottom here we have our fossils, right? And those are called index fossils. Index fossils are defined as having distinct features. They live globally, so they're not going to just be found in New York State or East Rockaway or whatever it is, right? They usually live for a short period of time, right? And are abundant, right? So they get preserved all over the place, okay? And so, this is, some of you maybe remember me talking about fidget spinners. That's a good time marker, something that we relate to, right? You can say, oh yeah, I remember having a fidget spinner in second grade or third grade or whatever it is, right? And then, yeah, some of you might still have your fidget spinners, but not everyone's spinning the fidget spinner these days, right? And so specific fossils are good time markers, right? And so what we're saying is all on the bottom here, when you find one of these in the fossil record, they mark and indicate a specific period in geologic time. So A, this type of trilobite, is a good time marker for the Cambrian, okay? You can pick any of these here, right? And just follow it across. Anyway, yeah, there's A, B, and C, okay? Bottom of the Earth Science Reference Table. We're continuing across. Okay, we're on this is page 9. I kind of folded it up, all right? And they use this word orogeny, all right, a lot. Orogeny, just a period of mountain building. And they show you the little pictures to show. This is the tectonic activity that's making our landscapes. Allegheny orogeny, formation of Pangea, okay? Akkadian orogeny, Taconian orogeny. Some of these words should sound familiar, like Taconic Mountains, okay? The Taconic Parkway, right? Taconic Mountains, you see that? Taconic Parkway is a road that we drive up through the Hudson Valley, and you're driving through the Taconic Mountains, right? And that formed all the way back in the Ordovician, long time ago. And then sure enough, they're showing where we think, look at this, North America sitting at the equator. Very cool. And once again, the fossil record is indicating that. Maybe the type of coral that are found in the rock record. Oh, this is characteristic of a tropical type of coral. You can see the landmass moving, okay? Anyway, there's a lot of good comments in here. Okay, so let's move on. Let's go to the Mesozoic. All right, here we go. Mesozoic, middle era, broken up into the Triassic, Jurassic, and Cretaceous, right? Running from about 251 million years ago to about 65.5 million years ago. Okay? Just zoom in a little bit. And yes, you generally think of the Mesozoic period as the age of the dinosaurs, the age of the reptiles, really. Okay? But there were other things going on here. Okay? Earliest mammals, all right? Earliest flowering plants, okay? Diverse bony fish, okay? And then sure enough, and I kind of cut it off here, but another mass extinction. And this is the one where we think, right? Major impact that basically, sends tons of dust and ash up into the atmosphere, blocking out sunlight, changing the climate. It was already believed because of the breakup of the continents, because of the climate was already changing, that the dinosaurs were already on their way to extinction. All right. It wasn't just the meteor impact that wiped them all out. A lot of them had already gone extinct. They were already on their way out. Okay. The meteor impact that we believe happened at 65.5 million years ago only just sped up the extinction process, okay, which gave rise to really us, all right, or I should say the Cenozoic era and the age of the mammals, okay. Anyway, so we've got the Mesozoic, right, Triassic, Jurassic, Cretaceous, right, 251 up to 65.5 million years ago. And just following it across, right? They talk about the Palisades sill. They're using words that we hear. Oh, they talk about Long Island, sand and clay underlying Long Island and Staten Island are deposited. Okay, interesting. All right, and look at where North America, you can see Pangea is breaking up. All right, Pangea. Oh yeah, Pangea is breaking up. Palisades, right? Palisades Parkway. You go over the GW Bridge when you're looking into Jersey over the GW Bridge, you're looking at the Palisades Sill, which we think is actually, and they're talking about the breaking up of North America with Africa, we think that that is like the hinge point where this divergent plate boundary began, where North America split from Africa. And we can match those rocks up in Northern Africa with the Palisades Sill. So there's some evidence right there. Oh, yeah, 2 months together, okay? Rock record similar, okay? Anyway, oops. All right. I'm just advancing. We go from Mesozoic to Cenozoic, right? The recent era, right? And sure enough, we take a look here. We zoom in a little bit. Paleocene, Eocene, Olivocene, Miocene, Pliocene, Pleistocene, and Holocene, right? And the Holocene is what we're living in. And some people actually might argue that we're past the Holocene because we're entering into another mass extinction. I'm not going to talk about that. You take AP Environmental Science, we'll talk about that. Okay, but this is the era that we live in, the recent era here. Okay, and mass extinction of dinosaurs occur at that boundary, right? Modern mammals, right? You can see humans, mastodons, and mammoths, right? You can think of Ice Age, right? Actually, Pleistocene is really the first Ice Age video is really the Pleistocene, all right? Somewhere between, I don't know, like 2 million years ago up to about, we think, and there were probably a few episodes, mini episodes of Ice Ages. We think actually 10, 15,000 years ago, we were still in an Ice Age, all right? Interesting. So anyway, advance a little bit, just a little, let's see, really, okay, good, okay. Organisms there, right? We go all the way across. We can see that the continents are pretty much looking the way we are familiar with. And sure enough, look, advance, this isn't lined up perfectly, but the advance and retreat of the last continental ice sheet should line up with the Pleistocene there. Okay? Oh, all right. So I think we're going to pause there. All right. Okay, so that is the Earth Science Reference Table, page 8 and 9. There's a lot of information there. You're probably going to have to go back through this video, all right, and really, look at it carefully. The biggest challenge, as I was saying, is this area over here, the Precambrian, right? They kind of break it up and then bring it down along here. But remember, they're only breaking up that 1.3 billion or the 1,300 to the 544, right? They're breaking that up over here. All right, and they're bringing it down. The rest of the Precambrian, they just have it sitting right in here, all right? And then boom, Phanerozoic, this whole table is pretty much the Phanerozoic, all right? So just remember that, right? So that's the geologic history of New York State, all right, page 8 and 9, all right? And of course, ask questions, reach out, email, whatever it is, all right? Hope everyone's doing all right. Hope to see everyone soon. All right. And I'm going to pause it there.